Good evening, students, Math 100 students. We're going to start on section 5.1, factoring the difference of two squares. The binomial x squared minus y squared is called the difference of two squares because x squared is the square of x and y squared, which is the square of y. This is the formula. X squared minus y squared equals to x plus y, x minus y. Well, we can substitute x for as a value, and y can also be a value as well. So let's start with some examples to kind of bring it home. Right? Factor x squared minus 9. I want you to think of your timetables. Give me two numbers besides 1 times 9 that will give you 9. There's only one thing that should be in your mind, which is 3 times 3. All right, so let's open up the parentheses. X squared means I can put an x in this parentheses and an x in this parentheses. Okay, I know that 3 times 3 gives me 9. And here, just looking at the formula, one has to be positive and the other has to be negative. Okay, if you want the positive here and the negative behind, that is perfectly fine with me, as long as you have one positive and one negative. This is your answer. That is it. Okay, that's it. Let's go to another one. Factor x squared minus 25. Besides 1 times 25, think of two numbers when you think of your timetables that will give you 25. Okay, hopefully you have those two numbers in mind. If I have x squared, I'll put 1x here, 1x here. I'm thinking of 5 times 5. I need one to be positive and the other to be negative, and that is your answer. So not too hard at all, not too hard at all. The next one, factor 25x squared minus 49. Okay, well, I know I'm thinking about 5 times 5. When I think of course, 25. But let me show you how you will break it up. So we know we need x here and an x here. We're thinking of 25. So I need 5 times 5. And two numbers besides 1 times 49 that will give me 49 are 7 times 7. Very good. So you have to be really strong with your timetables. Okay. And if you need a timetable sheet, just print one off online and use your timetable sheet. All right, so I want a negative. So in the formula, one has to be positive, the other has to be negative. So not too hard at all. Okay, let's try another one. Factor 4y to the 4th power minus 25z to the 2nd power. So let's first start off with our sets of parentheses. Okay, I'm looking at y squared here. So if I have 4, let me break that up so that it's even. Let me put a y2 over here and a y2 over here, or y squared here. All right, I'm looking at the number 4. Besides 1 times 4, think of two other numbers that I can multiply to get 4. I'm hoping you're thinking the same thing that I'm thinking, which is 2 times 2. Okay, now what about 25? When I think of my timetables, and I'm thinking of not just 1 times 25, but what two other numbers? 5 times 5. Very good. Very good. And with z to the 2nd power, that means I can put one z in one parentheses and another z in the other parentheses and just even it out. Okay. Now, the rule for the difference of two squares means one has to be positive and the other has to be negative. Okay. And notice difference means subtraction. Okay. Notice it says x squared minus 9, x squared minus 25, 25 squared minus. Okay, if you see addition, it will not work. Only difference of two squares. Difference means to subtract. Okay, to subtract. Okay, what if you saw one that said factor 8x squared minus 32 and you're thinking, well, Miss Thomas, that's not a perfect square. When I think of my timetables, I don't know any timetable that gives me 6 times 6 will give me 36, but they asked for 32. So what we want to do first is let's factor first. Find a greatest common factor, okay? All right, let's see. Let me think. I'm thinking about, let's see, my factor tree. And by this time, you can already have it factored out for yourself. So I'm thinking 4 is my greatest common factor, okay? And if you want to do your factor tree just to verify, just to make sure you have it, you may do your factor tree, okay? But you're going to get 4. That's what they have in common, okay? Now, if I have 4, I'm trying to get 8. 4 times what will give me 8? A 2. I need x squared. I don't have any. Bring that straight down. Bring down my minus sign. 4 times what will give me 32? and 8. Do I have a difference of squares now? No, still not now. Still not now. Should I have tried a larger number? Should I have tried a larger number? That's the question. Okay, so I wanted to make sure that you will be able to see when something is wrong. Because if I do, of course, I can do everything right. But I want you to visualize, well, Ms. Thomas, how come you didn't factor out another 2? That's what I want you to see. Okay, so right here, okay, so 4 was you thinking to yourself, okay, 4 is the greatest common factor. What if 8 was the greatest common factor? Okay, so what if, let's try trial and error, what if 8? Because many of you are going to try 4, like I saw on the rest of your assignments. You'll try the lower number before you try the higher number. Okay, so here, if let's say we try 8 instead. Okay, all right, I need 8x squared. I have 8, so I'm missing my x squared. Bring down my minus sign. 8 times what would give me 32? 4. Very good. All right, so now you can see, oh, okay, now that's the difference of 2 squares right there, Miss Thomas. Okay, so you have 2 sets of parentheses. Bring down to 8 because it has nothing to do with the x squared minus 4. Just bring it out front. But if we're putting x here and an x here, my timetables, I'm thinking about 2 times 2 and 1 positive and 1 negative. This is the difference of 2 squares. This is factoring out right here. Okay, so I have to give you, because I see common mistakes, and you will factor out a number that's not the greatest common factor. And you will hold on to factoring out what's not the greatest common factor. So this is an example of what I've seen on some of your work when it comes to factoring. Okay, early on, I'm just kind of looking. Okay, next. What about this, Miss Thomas? Can I factor anything out? Well, just looking at this particular problem, 3x squared, I mean, just off the top, 6 times 6 will give me 36. So that will work. I could put x and x, 1x here and 1x here. X times x is x squared. All right, I'm thinking about 16. Oh, I'm thinking about 4 automatically. 4 times 4, that'll give me what I need, right? But what's the problem? What about the y? Can I put y here and y here? Yes, you can. Okay, so what do I need next? A plus sign and a minus sign, and that's it. So I want you to be able to get a visual of what difference of squares mean, and just have it 2 times 2, 4 times 4, 3 times 3, 9 times 9, 7 times 7, 8 times 8. Those are differences of squares, okay? Right. Let's look at this last one. Factor 2x to the 4th power y minus 32y. Okay, well, what can I factor out? Okay, just looking at this, just doing my factor tree. All right, I'm thinking about 2y. Okay, well, I need 2. I have 2. I need x to the 4th. I don't have any. So let me put x to the 4th here. Okay, bring down my minus sign. I'm thinking of my timetables. 2 times what would give me 32? 16. Okay, now that's a difference of squares here. Okay, so if I put 2 x's in each one, 2 over here and 2 over here, that works. Okay, well, 16, I'm thinking 4 and 4, 1 positive, 1 negative. Okay, well, that works. Okay, am I finished? You could be, but here, this is a difference of squares. So just thinking about, well, Ms. Thomas, I think I can break this one down a little bit more to x and x. It has to be subtraction. I'm thinking 2 times 2. And if you are perfectly right. Okay, so let me tell you how you should write this one. Bring down your 2y. Bring down x squared plus 4. Okay, because it was a plus sign. Remember, all of these are subtraction. Subtraction. But this one was subtraction, and I was thinking that this is also a perfect square. So this will be x plus 2, x minus 2. So this whole entire thing is your answer. The whole thing. The whole thing. Okay? Very good, students. Very good.